This is a continuation of the Chapter 7 review with Problem 20. Problem 20 says, decide whether parallelogram JKLM with these vertices is a rectangle, a rhombus, or a square. Give all names that apply and explain. So the best way to attack this problem is going to be to graph it again. And so let's pull up a graph of this. And now let's take a look and analyze this graph and see what we can figure out. So we have to determine if it's a rectangle, rhombus, or a square. So the first thing we're going to do is we're going to determine the lengths of these sides. That'll determine whether it's in fact a rhombus. So let's take a look at this triangle and this triangle here. And let's see if we can draw on some things here real quick. And let's go this way, and let's do this and this. Now you can see that this is a right triangle and this is a right triangle. And if we take a look, we see that this side has length of 2, length of 2, length of 4, length of 4. So since this is a right angle and that's a right angle, these two triangles are congruent. Therefore, this side has to be congruent to this side by CPCTC. Now let's take a look at this side and this side. And let's pick a different color here. And let's do the same thing. Let's see if we can draw in a triangle here. Okay. And here. And here. Here. All right. Now we can see that again this side is length 2, length 2, length 4, length 4. So these two triangles are congruent, and that makes this congruent to this. Okay. So now I know that this is congruent to this and this to this. But now let's take a look at these two triangles. Well, since this is length 2 and this is length 2, length 4, and these are both right triangles, all four of these triangles are congruent. So that means that this is congruent to that, which is congruent to that, which is congruent to that. So I know that all four of these sides are congruent, therefore this is at least a rhombus. So the easiest way to determine these angles is using slope. So if we look here, we know that this has a slope of -2 over 4. So ML has a slope of -2 over 4, which is -1/2. This line has a slope 4 over 2. So LK is 4 over 2, which is 2. And 2 is just 2 over 1. You can see that these are negative reciprocals of each other. So this and this are perpendicular. So we know that this has to be a right angle. And if we look here, we see that this slope is 4 over 2. So this must be a right angle, because if JM also has a slope of 4 over 2, which is 2 over 1, and ML has a -1/2, that these two are perpendicular. So this one is a right angle. And KJ, the same idea. KJ, -2 over 4, -2 over 4, which is -1/2. So this is a right angle, and comparing KJ and JL or KL, we can see that these are perpendicular as well. So what we come with is this is a rhombus because all four sides are congruent. It is a square because all four of these angles and sides are congruent, and because it has 4 right angles, it's also a rectangle. So for number 20, this is a rectangle, a rhombus, and a square. And there's the answer. Now on to problem 21. In problem 21, it says find the measure of each angle in the isosceles trapezoid. The properties of an isosceles trapezoid are the base angles are congruent, so this is congruent to this, this to this, and the consecutive angles are supplementary, so this and this are supplements. So I know that this angle has to be 58 degrees. 58. And these two are supplements, and so we have that 180 equals 58 plus angle W. Subtract 58 from 180, and 122 equals W. So we know that this angle is 122, and this angle is 122. And there we have problem 21. And now on to problem 22. Problem 22 says, find the length of the midsegment of trapezoid ABCD. So ABCD. And this is employing the midsegment theorem. And the midsegment theorem says that the midsegment is 1/2 the sum of the two bases. So let's go ahead and calculate that. So here we have problem 22. And we know that the midsegment is 1/2 39 plus 13. So that's going to be 1/2 52. So 52 divided by 2 gives us 26. And so the length of this midsegment is 26. And now on to problem 23. Problem 23 is a little less pleasant than problem 22. It requires yet another graphing solution. So what we're going to do is we're going to graph this trapezoid again. And so let me bring that up. And we need to find the length of the midsegment. Now, the definition of a midsegment is a segment that connects the midpoints of the legs of the trapezoid. So I need to find the midpoint of this side and the midpoint of that side, and then I'm going to have to use distance formula to find the distance between them. It's either that or find the distance of this, add them together and divide by 2. Obviously, it's easier to find the midpoints and then use the distance formula once. So let's get started with that. So for 23, we have this midpoint is going to be the average of the endpoints. So it's going to be 6 plus 10 over 2 and 10 plus 6. 10 plus 6 over 2, which is 16 over 2, which is 8, and 8. These are the same. So it's going to be 8, 8. So this is my point. Okay. Now we do the same thing for this, and we have 2 plus 8, so 2 plus 8 over 2, and 2 plus 2 over 2. which gives us 10 over 2, which is 5, 4 over 2, which is 2. So it's 5, 2. And there's our second point. Now, to find the distance between these 2 points, this is 5, 2, and 8, 8. We're going to use distance formula. So we have 8, 8, and 5, 2. So 8 minus 5 is 3. 8 minus 2, 6. Square, add square root. So this is 9 plus 36, that's 3. Square root, this is square root of 45. And we can simplify this, since 45 can be factored into, 2 doesn't go into 45, so let's go to 3. 3 goes into 45 15 times, and 3 goes into 15 5 times. So here are our prime factors, and each pair comes outside the radical as 1, so this is 3 square roots of 5, or approximately 6.71. And that's problem 23. Now on to problem 24.